Number 1, solve the radical equation. So when we solve a radical equation, the first thing we want to do is isolate the square root. I want to get the square root all by itself. So I'm going to subtract 4 from both sides and get 3 square roots of 6 minus x equals negative 12. Well, the square root's still not by itself, so I'm going to divide by 3 and get the square root of 6 minus x equals negative 4. Now that I isolated the square root, I'm going to square both sides, because that's the inverse of square rooting, is squaring. So squaring and square rooting undo each other, so I have 6 minus x equals 16. I'm going to subtract 6 and get negative x equals negative 10, so x equals 10. However, we just can't go and circle that answer. We have to go back and check. We have to go back and check and say, what's 3 times the square root of 6 minus 10 plus 4? Is that equal to negative 8? Well, that gives me this 3 times the square root of negative 4. Uh-oh, that's a problem. Plus 4 equals negative 8. The square root of negative 4 is not a real number. That's not a real number. So, x equals 10 is extraneous. So we have no solutions. Or we could represent that by just an empty set. Explain why the calculation above does not produce a solution. Well, we knew back here at this step that there was no solution. I knew once I got to the step of the square root of 6 minus x equals negative 4. I knew right here that there was no solution, because square roots can never equal negative numbers. The square root of what? The square root of chicken nugget gives me negative 4. The square root of what gives me negative 4? This is not a real number. It does not exist. There's no number that I can square root to get negative 4. So at this point right here, all the way back there, I knew there was no solution. Number 2, 3, and 4, solve each equation and check the solutions. So I want to isolate the radical. In this first one, it's already isolated, so I need to square both sides. When I square both sides, that undoes the square root, and I'm left with x squared plus 9 equals 25. Well, it's a quadratic equation, so I'm going to want to set it equal to 0. Subtract 25 and get x squared minus 16 equals 0. Factor x squared minus 16 is the difference of perfect squares. So we get x equals negative 4 or x equals 4 once we apply the zero product property. So x equals plus or minus 4 could be solutions. I now just need to check them. When I do the square root of negative 4 squared plus 9, does that equal 5? Well, that gives me the square root of 16 plus 9, which is the square root of 25, which equals 5. So it does check out. And if I change this, and if I change this now to just be not negative 4, 4, well, 4 squared is still 16, so they both check. So x equals plus or minus 4 is the solution. Those are both solutions to this equation. Number 3, that square root is not isolated, so I could square it, but it's not the best idea yet. I want to divide by 2. The square root of x plus 3 equals 6 divided by 2 is 3. How do I undo a square root now that it's isolated? I square both sides and get x plus 3 equals 9. So x equals 6. I need to check though. 2 radical 6 plus 3, does that equal 6? Well, 2 radical 9, does that equal 6? Well, 2 square roots of 9 is 2 times 3, which does equal 6, so it does check out. It does check. So x equals 6 is the solution. And finally, I need to isolate my radical over here. It looks confusing, though, the order that it's written in, but I'm going to have to subtract that 5 over. Negative 3 square roots of 4 minus x equals negative 3. And divide both sides by negative 3. And get the square root of 4 minus x has to equal positive 1. Square both sides now that I isolated the square root. 4 minus x is 1. Add x, subtract 1, and you get x equals 3, because 4 minus 3 is 1. Is it actually a solution, though? Well, I need to plug it in. 5 minus 3 square roots of 4 minus 3. What does that equal? Gives me 5 minus 3 radical 1. Square root of 1 is 1, so 5 minus 3 equals 2. I want it to equal 2, so it checks out. So x equals 3 is the solution. I had no extraneous solutions here. They all checked out. I could have, though. Number 5, solve the equation algebraically. Let's do that first. So it's a radical equation, so I need to isolate the radical. I'm going to isolate the square root by adding 3 to both sides. How do I undo a square root? I square both sides. X squared minus 6x has to equal, so I square both sides, I have to equal 16. This is a quadratic, and I solve quadratics by factoring and setting it equal to 0 and then factoring. So x squared minus 6x minus 16 equals 0. It's a trinomial with a leading coefficient of 1, so I don't need to go through the whole AC method. But what multiplies to negative 16, that adds to negative 6. Negative 8 and positive 2. And now we can use the zero product property and say if I multiply two things to get together and get 0, the first term is 0. That happens when x equals 8, or the second term equals 0. That happens when x equals negative 2. I'm not done yet, however, because I need to check both of these solutions. The square root of 8 squared minus 6 times 8 minus 3, what does that equal? Hopefully it equals 1. We get the square root of 64 minus 48 minus 3. Well, that's the square root of 16 minus 3. 4 minus 3 equals 1, so that one does check out. X equals 8 is in the solution set. What about negative 2? Well, negative 2 squared minus 6 times negative 2 minus 3, what does that give me? The square root of 4 plus 12 minus 3. That's the square root of 16 minus 3, which we already said is 4 minus 3, which equals 1. So x equals negative 2 is in the solution set. I had no extraneous solutions. Great, so you can solve this algebraically. Can you solve this graphically? So let's let f of x be this side of the function, this side of the equation, that's f of x, and we'll let g of x be 1. Graph both functions and explain how you found the solutions to f of x equals g of x. Well, f of x equals g of x is that equation back there. When are those two functions equal? What x values make those two functions equal? So let's graph them. So go to your TI-80 something. I have a TI-84. And on my TI-84, in y1, I put that first function, and in y2, I put the second function. I'm going to look at a graph. So that weird square root function is the blue graph here, and the line y equals 1 is the red line. So let me sketch that quickly. Let me get a sketch of this graph. So that weird blue function, which I'm going to graph as green, looks something like that. It looks something like that. And then it started up again over there. There's that weird square root function. That green function is f of x. It went on and forever that direction. The boring line is g of x. The boring line is g of x equals 1. That's that horizontal line there. So from the graph, I see that there are two solutions. I see that there are two solutions to this equation, f of x equals g of x. The question is where? So I'm going to go to second calc and go to intersect. Second calc intersect. I need to get close to the first intersection point. That looks pretty close to it. Hit enter 3 times, and they intersect at x equals 8, y equals 1. When I care about the solutions to f of x equals g of x, I just care about the x values. That happened at x equals 8. What a surprise. X equals 8 is what we got algebraically. Let's go find the other one. Second trace intersect, number 5. And I have to scroll all the way to the other one. Hit that arrow a bunch of times. So that little cursor there, that little flower type thing, gets closer to that second intersection point. You're going to have to hit it a lot of times. It's obnoxious. I apologize. Blame Texas Instrument. Just kidding. Texas Instrument is great. They make these great calculators for us. Oh, I hit it too many times. It's going to just keep going. Oh, there we go. Get close to it and enter 3 times. And these intersect at the point -2, 1. But when I care about what's the solution to f of x equals g of x, I only care about the x value. And that happened to be x equals -2. So x equals -2 is the second solution, which is exactly what we got algebraically. So we can solve these equations both graphically and algebraically. It's a very powerful tool that we have at our disposal. Number 6, without actually solving the equation, explain why this equation has no solutions. Well, just looking at this equation, I have the square root of x plus 1 plus 2 equals 0. This quantity here is always positive. Well, it's always non-negative. Always non-negative. It's either positive or 0. So it means it's either positive or 0. Well, what plus 2 gives me 0? This thing would have to be -2. That thing, that quantity, that square root of x plus 1 can never be -2 because it always has a positive value or is 0. So that's why there's no solutions, because the square root of x plus 1 is always a non-negative quantity. That was lesson 9.